question where we've been asked to find the length of the curve y equals x cubed on 2 plus 1 on 6x from x equals 1 to x is equal to 5. We know our formula for working out the length of the curve is length is the integral from a to b of the square root of 1 plus dy dx all squared dx. So let's see what we have. X is equal to 1, there's A. X is equal to 5, there's B. And we have an expression for y. If we differentiate that expression, we now have dy dx. So y equals x cubed on 2 plus 1 on 6x, which means x cubed on 2 plus 1 on 6x to the minus 1. Differentiating this, dy dx is equal to 3x squared on 2 minus 1 on 6x squared. So now we're ready to substitute into our formula. L is equal to A we said was 1, B we said was 5, square root of 1 plus dy dx all squared. Dy dx is 3x squared on 2 minus 1 on 6x squared all squared dx. So what we're going to do is expand our bracket. When we expand our bracket, we get 1 plus 9x to the 4 on 4 minus 1 half plus 1 on 36x to the 4 dx. Now we're going to combine the 1 and the minus a half. When we do that, we now have 1 to 5 as our integral, square root 9x to the 4 on 4 plus 1 half plus 1 on 36x to the 4 dx. Now for some observation. We know what happened when we squared 3x squared onto minus 1 over 6x squared. We got a middle term with minus 1 half. When we added the 1 and the minus a half, we've got a half. By observation then, what we know then is the integral from 1 to 5 of the square root of 3x squared on 2 plus 1 on 6x squared all squared dx. We have a square root and a square. They cancel each other out. So we have the integral from 1 to 5 of 3x squared on 2 plus 1 on 6x squared dx. That is the integral from 1 to 5 of 3x squared on 2 plus 1 on 6x to the minus 2 dx. Anti-differentiating, we will get x cubed on 2 minus 1 on 6x between 5 and 1. Substituting in the value of 5, we get 5 cubed on 2 minus 1 on 6 times 5 minus substituting in the value of 1 cubed on 2 minus 1 on 6 times 1. That will end up giving us 932 on 15. We're working a length, it's a linear distance, so units. We could also have used our calculator to work out this answer. You can see here from the calculus menu, I have selected arc length. When you select arc length, it puts in ARC, LEN, arc length. You have to type in what the function's equation was, not with y equals, just the part at the end after the equals sign. Identify the variable, in this case x. You have to indicate the starting point, which was 1, and the finishing point, which was 5. This gives us the answer 932 on 15, which matched our answer when we did it by hand.